Okay, welcome everyone to the session. We are doing exam past papers. So I'm gonna be starting with the grade 10 paper 1. It's last year's paper, but it's exemplar, so it's like practice exam paper, grade 10 paper 1. So I'm gonna try to do it in as short time as possible, but it's 100 marks. It should be written in 2 hours, but we don't have 2 hours, so we're gonna just get right into it and then see how many questions we can answer in 30 minutes. So first things first, when you get to the exam, go through the instructions, make sure you understand whatever it's given. And I want to highlight point number 7, if you can see it there, where necessary, answers should be rounded off to 2 decimal places unless stated otherwise. So if they haven't told us anything, if we have find a question that has decimals, we should round off to 2 decimals, blah 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 blah. Okay, let's get started. So the first question, I'm gonna work on this answer sheet, so I hope you can see. So the first question is x squared plus x minus 42. So obviously the first question says you must factorize. You must have your calculator with you. Okay, so we're going to look for the factors of 42. It's a trinomial. So how do you solve a trinomial? Cross multiply, and then here I'm going to write the product of x squared. Here I'm going to write the product of 42. Okay, let me just check here. The factors of 42, it's what and what? It's 6 times 7. It's 42 times 1. What else will give you 42? Okay, whatever, but already you can see the factors of 42, which will give you, remember when we factorizing a trinomial, we're looking for the product of the first term and the last term to give us the middle term. So we want the factors that when we subtract them, we look at this sign here, minus, we should get the middle term. So I can see if I subtract 6 from 7, I'm going to be left with 1. Because here, if I subtract, I'm going to be left with 41. So here I'm going to write x, and then I'm going to write what there. 7 and 6, you cross multiply to check. 7 times x is 7x, 6 times x is 6x. If I subtract, how do I know you're adding or subtracting? You look at the middle term, the last term, sorry. This one tells you that you should add or subtract the values. So you get 1x, which is the middle term. You get x. Therefore, these are your factors. So I'm going to have x7, x6. Now, here it also tells you that the signs should be different in the brackets, should differ, and then if they are different, the sign in the middle term will go to the bigger number. So the bigger number between 6 and 7 is what? 6. This one will have that one. So that's your answer right there. For how many marks? For 2 marks. Straightforward. It is not an equation, it's an expression, so we leave it like that. Cool. So I haven't done this paper. I just took it online. So if I do any mistake, I'm making a disclaimer. You shouldn't crucify me. We're trying to figure it out together. So sorry about that. So here, what are we going to do? We're going to try to factorize. So what I'm going to do, I'm just going to take them as they are and then take out a common factor. So let's take it like that. Remember, you have to introduce a plus in between. It's for grouping. Remember, when you have 4 terms and you're supposed to factorize, you apply grouping. So I'm going to have 2ab squared minus b3 plus b squared minus 2ab. If I factorize, I'm going to take out a common factor here. Common factor will be b squared. So I'm left with what? 2a minus b. Do you agree with that? Plus, take out a common factor there. It's b, a number that appears, or a term that appears in both the terms. So I'm left with 2a. Okay, cool. Then what do you realize? That you realize that you've got the same terms in the brackets, but the signs are different. So you're going to introduce a negative sign. So b squared minus 2a minus b. I'm going to introduce a negative sign before. This is still positive, so that I change the sign in the bracket. So 2b minus b. Then this a negative and a positive will become a negative. Inside the bracket, a negative and a positive will be a negative, and a negative and a positive will be a positive. So I'm going to start with this one. A negative and a negative will be a positive. A negative and a positive will be a negative. So I don't have to write the brackets now. So you can see, remember, the whole concept of factorizing is to identify the common factor. So these two are common factors. So I'm going to have what? 2a minus b into, then I group the other ones. B squared minus b. So take out a common factor there. B minus 1. So the answer will be b, 2a minus b, and b minus 1. Here there's a common factor. So you need to factorize fully according to the question there. Factorize fully. Make sure you factorize everything. All right, let's do this one. Yeah, it's becoming, it's becoming. So I'm gonna do 1.3 right there. 1.1.3 says what? 3 minus 27 over x squared. Yay. So how do we do this one? We are supposed to be factorizing. So what are we gonna do? What is the first thing that we are going to do here? Okay. So firstly, if there is no mistake, because I would have thought that they'll put a cube here and then I'll factorize it using a cube. So if it's like this, remember we have those three things. We look for a common factor. Do we have a common factor between the terms? A number that appears here and there? Yes. 3 minus 27 is made by what? What are the factors of 27? Will be 27 equals to, okay, let me show you here. How do you look for factors? We press 27 equals sign, shift, fact. So it's giving us the factors of 27, which is what? 3 cubed over x squared. So I'm gonna take out 3 outside. 3 outside, so I'm left with 1 minus. If I take out 3 here, I'm gonna be left with what? I'm gonna be left with 3 squared. I hope I'm not losing anyone. Okay, if it's like this, I can simplify it. 3 squared is 9 over x squared. So I took out a common factor. And then the next step, remember we have 4 common topics under factorization. We're going to look for a difference of 2 squares. Difference of 2 squares, I hope you still remember it. It says if you're given a square and a square with a minus in between, you're going to have what? Plus a negative and a positive bracket, and then you find the square root of each. The square root of x squared will be xx, the square root of y will be yy. So you're going to have something like that. And then I have a difference of 2 squares there, because 1 is a square, 9 is a square, x squared is a square. So I'm going to simply do that. I'm going to have 2 brackets. Another one is first one is a positive, another one is a negative. Oh, sorry about that. Square root of 1 is 1, 1. Then the square root of this. Remember, according to the rules of square root, a square root of a fraction can be separated as like individually, like you can find the square root of each. So the square root of 9 is 3 over x, and then that one will be 3 over x. Yeah, that will be your answer there. I hope. I really hope. Yeah. So let's say you're in the exam, you find a question like that, you don't know what to do. The best thing is to do what? To skip it, and then you'll come to it later on because of your working under time, and then you need to cover as many questions as possible. So in this part, I can maybe do few questions because I don't want it to be long, and break it into small bits. And then let's see. So now we are on 1.2. We are supposed to simplify. Simplifying, we all know. The catch is just to multiply out and then add the like terms. You need to make sure that you don't miss the signs and everything, and you add the like terms, and then you have something like that there. Okay, we'll see. We'll cross the bridge when we get there. Crossing the bridge. Okay, 1.2, 1.2.1, 4a squared minus 2ab plus b squared, 2a plus b. Okay, so with this one, what are we gonna do? We're gonna multiply out, right? Multiply. Okay, you can do it like this, or you can make your life easier. Take this one, bring it there, so that you multiply a binomial with a trinomial. It works better, but it doesn't matter. So I'm going to multiply everything in the second bracket by this one. So 2 times 4 multiplied by 2, it's 8a cubed, and then that one will be a positive 4a squared b. Right? I'm done with the first term, going to the next term. Minus 2ab multiplied by everything in the second bracket. So a negative and a positive will be a negative 4a squared b. Just be careful with the signs there. All right, and then minus 2ab squared, and then we do the last one, plus 2ab squared plus 2b cubed. And then we identify with the other pen. We identify the like terms. So obviously this and this are like terms, and this are like terms. Oh, okay, this one works quite nicely. So it's a cube, eh? It's a cube. So what's gonna happen? This and this goes out, this and this goes out, because we have a positive 4 and a minus 4. Minus 4 is 0, to that one is 0. So you're only left with 8a cubed plus 2b cubed. So this one, if you were to factorize it, is what? Is the sum of cubes. Sum of cubes. Yeah. Luckily we're not factorizing it, but if we were factorizing it, it will be, yeah, it's working out quite nicely there. Let's go on. 1.2.2. You've got this man there. This man needs to be solved. How do you do it? Oh man. So if we get stuck, we are jumping this question. So I don't know there. Is it a negative? Should I bring it close? Is it a negative, or is it a wait. Here, this line looks a bit longer. Is it a negative or a fraction? I don't know. So I don't know if there's a negative sign here. It's not clear on the paper, but we can just move on. -8. Okay, let's try it. So this thing is the same as a cubic root. Cubic root is something like this. Can I write it here? If they give you x3 1/3, the numerator and the denominator is going to cancel out, and you have this. This is the same as having this. I don't know if it makes sense. this is a root. So what you can do, you're gonna multiply all the exponents inside the bracket with 1 over 3. So obviously 8 can be written as what? As 2 that and like that. I'm not losing anyone there. I just changed this one. Plus 2x minus 4 minus x minus 8. Okay. So this multiplied by that will give me 2. This multiplied by that will give me 4. Just multiply them. Like 3 and 3 is like 3 over 3 is going to be 1. And then 12 over 3 is going to be 4. So you just multiply it in with the exponent there. And then you have 2x minus 4 minus 8 like that. Okay. Then we're going to multiply. The rule about multiplying exponents says when multiplying parts of the same base, we add exponents. So 2 times 2, obviously it's 4x, and then this one 4. 4 plus minus 4 is going to be 4 minus 4 minus 8. So this was going to be what? 0, I hope. I think, yes. It's going to be 0 minus 8. And then anything to the exponent 0 is 1. So we're going to be left with 4 minus x minus 8 there. Right? And then there's a rule as a property. It says something like this. If you've got a negative exponent, you can write it as a fraction. So we can write this as a fraction as 4. If they say leave it as a positive fraction, 1 over x8. Yeah. This is provided that here there's no positive, there's no negative answer. I'm gonna leave it like that. I don't think there's anything further to be done. We're simplifying, so we don't need to factorize, so we're just simplifying the question. Okay, so this is just term 1 work. So if you forgot a bit about it, you need to go and revise it. Let's try this question here. It's exponents. So I'm going to try to write bigger here so that even if you can't see the paper, you can see what's happening on the answer sheet. Or on the answer sheet. Is it on or in? Okay, and then 4 there. So this dot means multiply. Everyone knows that. So the first thing that we do, I call it the reverse of law 1. So law 1 says this. Can I write it here? Law 1. The first law of exponents says when we're multiplying powers of the same base, we're gonna add the exponents, right? So when we go in there, if you've got a base, what am I saying? A base and a base. We're gonna have one base, and then you're gonna have the addition of that. So if you are to reverse it from here to there, if you break down the exponents, each is going to have its own base. Can you see? So if they give you this one, initially, before it became like this, it was like what? It was like, can you see? Each of the exponent had a base. So I call it the reverse of law 1. We are reversing law 1. So we're going to do that. First thing, we're going to reverse law 1 there. Reverse law 1 dot and multiply the same thing. Can you see what I did? And then we're gonna reverse law 1 there. 2n and 1 over 49 is made by 7 squared. So 7 squared. Then there's n outside. I hope I'm not losing anyone. Where did I get the 7 squared? 49, it's made by 7 squared. Then once you do reverse of law 1, so here reverse law 1, you're gonna factorize numerator and denominator. You're gonna identify factors that look the same. So this one and that one. Once you've got a plus or a minus in between the terms, you are allowed to factorize. Okay, you're allowed to factorize this one. You can take this one out or you can leave it. It's gonna work itself out. You can take this one out or you can leave it. Okay, so let's deal with this ones. So here you've left, when I take this one out, I'm left with 7 squared there, and then I'm left with what there, minus 3. When I take this one out, I'm left with that one there over 7, 2n, and 4. So this one and that one are gonna cancel out because of they are the same. They don't really cancel out, it's like 1. Or if you're applying exponents, you're subtracting them the same, so you're gonna get 1. I hope you get it. And then there we have 49 minus this one is 21 over 4. 49 minus 21, it's 28 over 4. It's how much? Yes, it's 7. So I'm sure even if you took this one out as a common factor, yeah, you'll be left with what? Am I right? Between these two. But it's gonna work itself out because it's a constant, so you don't really have to worry about it. Okay, let's move on. Yeah. All right, let's go on. How much time do you still have? We're on 21 minutes now. Yeah. Okay, then we have this question. Yeah, this one, if it doesn't work out, if you don't get it, forget about it. Or if I don't get it, I must forget about it. Without the use of a calculator, 6 to the raised to the power 7 equals to x. Determine the value of this expression in terms of x without the use of a calculator. So let's try this question, but I really don't have a clue now what we're gonna do, but let's try it out. They say if x is this, they give us the value of x, and then they say find the value of 62534435. Find the expression of this in terms of x. So what are we gonna do here? The first thing I would do is to break this down. I mean, it's out of 3 marks, so even if you get 1 mark or 2 marks or 2.5 or 1.5, it's something, you know, it's better than nothing. So the first thing I would do is to break this one down. So I can multiply this. Yes, I can multiply this out. So 6 is made by, what are the factors of 6? It's made by this. It's made by what? It's made by that. So I can multiply each by that. Am I right? I hope I am right. 2, 7 multiplied by 3, 7. Yeah. And then here I can try to break this down and then see where it leads me. So here, if I break this one down, I also have 2 and 3 squared. 5, I'm just going to write it like this. And then 4 is made by 2 squared. Yeah, no, if it doesn't work out, it doesn't work out. 3, no, what am I doing? There's nothing there. So 2, 2, 3, 2, 5, 3. So this one will be 2 what? 2, 6. It's not 2, 6, it's 2, 8. And then 3, 5. So I'm gonna add the like terms. This one is 2. Is 2 plus 8. This is 8, right? Do you know how I got the 8 from here? 2 times 4. And then this one, 3, 5 plus that one is 7. And then 5, 3. Okay. These people are making noise. That's why I can't concentrate. They're making noise for me, man. Why are they making noise with their loud music? So here, what will be the easiest thing to do here? I can relate this and that one. I think if I divide both sides by this one, let me see, if I say 37 equals to divide both sides by 2727, I'm going to have x is equals to 2 the exponent of 7. So I can replace this by 210x over 27 over 53, and then I can, when dividing parts of the same base, you can subtract. So I can do this: 10 minus 7 x 53, 10 minus 7 is 3, I have x, I have 53. I think it works. So these are the same, I can put them together. So 2 and not 5, 3x. So something like this. I think maybe. If I'm wrong, you'll tell me. If you've got a simpler method, you'll tell me. So what you can do, rewind the video and check it out. That's what I did, but I'll end here. So yeah, let's go on. Let us go on. If you don't get it, don't worry about it. It's only 3 marks. You won't die by losing 3 marks. Whoever died? No one. Why we are still alive? All right. Okay, let's continue. Okay, how do we do this one? So as a solve for x, we the solving equations here. So the best thing will be to change this one. Change this one into what? Into a fraction. A square root can be changed into a fraction. So I'm going to have 16, 1 over x. This one here becomes the what? The denominator when you make it a fraction. So I can deal with this man here. 16 is 2 exponent 4, 1 over x. And then, what can I do here? I can write this as I can multiply this together, yes. So 2, 4 over x is 2, 1. When multiplying, if the bases are the same, when solving equations, you can drop the bases. Yes, you can drop the bases, and you're left with what? 4 over x equals to 1. And then multiply both sides by x, multiply by x, x and x cancels out this side, and then you have what? 4 equals to 1 times x. So x is 4. Then with the equations, what you can do, you can work it out. You can actually go to the calculator and check if we are right. Yes, we are right. So the value of x is 4. So the catch here, can I just explain it quickly? The catch here is to make these two things to look the same. The exponent here and the exponent here must be the same. If they give you something basic like this, what would be the first step to do? Change this into a prime base. That's what I did. I changed the 16 to be a prime base. This one stays the same. 9, if it changes to a prime base, it becomes 3 squared. And once you have the same exponents there, you can just drop the bases. Same bases, drop the bases, equate the exponents. So this and this goes out. X is 2. Same as if you have this, maybe x2 and what, and like something like this. If the exponents are the same, you can drop the exponents and equate the bases. So it works interchangeably. I hope that's the word. All right, let's go on. We are in the examination room. So far, so good. Okay, minus x, 2 minus x. Yeah. Yes. Okay. All right. Do you get a question like this? You need to simplify. Not a train smash. You just need to take it step by step. Take it one step at a time. One day, one step a day. Okay, whatever. The first thing you'll have to change this one into, factorize this as a trinomial, and also on top, can you factorize? No, we can't factorize this one because of this 2. it's not the same. Yeah, so the only thing you have to do is change this one, and also here I see that I might have to multiply with 1 there to change the symbols there. So okay, 2x squared minus 25 over factorizing a trinomial, factors of 6, when I add them up together they must give me 5, will be x plus minus, so the symbols are the same, and we take the symbol of the middle term, so it's like that. So you see this one and this one are almost similar, so I'm going to multiply this whole term by minus 1 so that I have it to look like that one. Okay, so if you multiply by -1, it's going to change the sign, and then you're going to have something like that, and then put all the denominators in brackets. Then we're going to look for what we call the lowest common denominator. Lowest common denominator, it's then a denominator. It's an expression where all the denominators can go in without a remainder. So which one is it? Is this one. Is this one, because of this one can go in, and this one can go in, and this one can go in without the remainder. Once you identify the LCD, you multiply all these things with the LCD. So usually I always use a different pen. So x minus 3, x minus 2, you multiply by the LCD. So x minus 3, x minus 2, multiplied by x minus 3, x minus 2. So remember, this is the numerator, this is the denominator. So this one and this one will cancel out, this one and that one will cancel out, this whole thing and this whole thing will cancel out, and you write only what you're left with. So on top you're left with x minus 2 plus x is x plus 3, minus 3, is it minus 3? Yes, minus 3 equals to 2x squared minus 25, and you multiply in x squared minus 2x plus x squared minus 3x. Then I can take this to the other side. It becomes a plus. So this and this and this will go out, because x squared and x squared will give you 2x squared and then minus x squared. And this and this will give you minus 5x plus 25 equals to 0. Take the 25 again. I don't know, why did you bring it this side? Why did we bring it this side? This and this goes out. You're left with x. X goes into that 5. Yes, I think. Then what do you have to do? Take this, if you have the time and the energy for life. Take this 5, put it back into that whole thing. You must get the left-hand side must be equal to the right-hand side. The numbers, the answers must be the same. Yes, we are at 33 minutes now. Okay, let's go on. We're here now. Yes. So we're still on question 1 because of I'm taking time to explain. If I was not taking time to explain, I'll be long. I'll be finished. Obviously, I wouldn't be finished. But let's try. Let's try to push it. We're given 2.2. It says we're given this 0 equals is less than 3 minus x over 2 and that. Yeah? Okay, solve. 2.2.1 says solve the inequality. So obviously we've got an inequality, we have to solve it and write down an integer that will make the equation invalid. Okay, an integer. All right. 2.2.1. so what will be the first thing? We're going to take the constant to both sides, so it becomes negative, right? Yes, it becomes a negative. 2 minus 3, so yeah, 0 minus 3, so the answer is 3 there. X is 2 and minus 1. Then we're going to multiply both sides by 2 to get rid of the fraction. always, if you want to get rid of the fraction, you multiply both sides or everything by the denominator. So I'm going to multiply it by 2 times 2 times 2, and this 2 and this 2 goes out. I'm left with x there. This is minus 2 now, and this is minus 6. I'm going to multiply with the negative minus 1. Yeah, why am I doing that? Because I want a positive x. And then when you multiply with the negative, it changes sign, right? This one becomes like that, and this one becomes like that. So x is between, so basically I can write it like this. X is between what? If you were to write it on a number line, x is anything in between. So write an integer that will make this thing invalid. So anything beyond this wouldn't apply. I guess that's what they're asking. Any number that will not apply, it's any number that is less than 1. Anything going there wouldn't apply, and anything going there more than 6 wouldn't apply. So yeah, anything less than 2 or anything greater than what? Greater than 6 wouldn't apply. Yeah, will be invalid. I think that's what they're asking. If that's not what they're asking, okay. So we are done here. We're doing simultaneous equation. So with simultaneous equation, I always prefer using the substitution method. For this one, it wouldn't be hard, I guess. Yeah. So there are 2 methods of doing it. In grade 10, they teach you 2 methods: the substitution method and the elimination method. But it's always easier to learn the substitution method, so that when you get to grade 10, you get to grade 12, you don't have problems. Because elimination method, you can solve it, but it's gonna be a bit complex. So when you go to grade 11, it's not really necessary. It's not really necessary. So you can just solve so this is equation 1, equation 2. Okay, so what am I going to do? I'm going to try to simplify this so that I can easily use the substitution method. How will I simplify this? I can see that all these are multiples of 2. So I can divide by 2 everywhere, and I'm going to get something like this. Can you see I divided everywhere by 2 by 2 by 2? It's still equation 1, but it's a simplified version of equation 1. So I'm going to take equation 1 and then try to make x the subject of the formula, because it has coefficient 1, so it works easier. This one goes there, it becomes a positive. I can make this equation 3. So this is the new is the manipulated equation. So I'm going to say substitute equation 3, call it the new equation, into, now you're going to have to choose the other equation that you didn't use. So the other one is what? Equation 2. So equation 2 is something like this. Wherever I see x, I'm going to put this whole thing. So 3 plus 2y minus 5y equals to 10. This and this is 9, plus this and this is 6y minus 5y equals to 10. This and this is y. And then take, hey, are you here? Why are you not? 10 minus 9, take 10 that side, so y is 1 according to this. And then go back to equation 3 to get the value of this one. So substitute the y value that we got into what? Into equation 3 to get what? What are we looking for? To get the value of x. We want the value of x. So 3 plus 2y, 3 plus 2 open bracket, it's 5. I think it's 5. Then we have to work it out and see if we get what we are getting. So what are we going to do? I'm going to take the first equation, 2x, I got it as 5, we must get 6, minus 4, 1. And you pray that you get the answer. Yeah. You see, you can try to do the other one. So the value of x is, yeah, for 5 marks. 5 marks is a lot. Yeah, so we're done with this. Question 1 and question 2. How to answer question 1 and question 2. Yeah, I can call it like that. I can name it like that. Ne? And then we have to do patterns here. Patterns, you either given in grade 10 it's only linear, grade 11 it's linear and quadratic. But for this first part, it's almost the same for grade 10, 11 and 12. Grade 10, 11 and 12. So let me just pause the video here and I'll make another video on patterns separately and then functions. Yes. Okay, just comment, tell me what you think of this. I might have made mistakes. I didn't check this question before. I just took it from the government, okay, and just worked on it. So I'm trying to show you the mistakes that you might do, how to analyze a question, what to do when you're faced with a question. Yeah, so let me know what you think. Like if you enjoy the video, and then I'll make another one just now. Thank you.